Alright, hello and welcome to my video. In this video I'm going to show you the small game I made for the Hand-in 5 in procedural programming. First off, I'm going to show you the game. So here it is. It's a dual screen, one with the console where you can see stats and shit like that, and the other one is the actual gameplay over here. Let me just move it a bit around. So the game is basically you are Bob, which is this green circle, which moves around the maze here, and you try to avoid Anton. As I move around, you can see that there are certain treasure I can snatch up, and each time I snatch a treasure, my treasure hold gets increased by 1. Now this thing chasing me is called Anton. Anton is this guy that tries to eat Bob because he hates him. Now Anton is attracted to these orbs, but as I move with Bob, they get teleported back. So the fight system and flee system, in a sense, is conjunctioned. The way I do it is basically when you click, the balls fly over to this area, and so does Anton, and you have some time where you can refresh and think of the next move. Now, as you may have noticed, that Bob has this teleporting ability when he goes to the right. This is a feature, let's call it that. It's not intended, but nonetheless, you can teleport. It's awesome. Teleportation is cool. So basically, you try to gather all the coins without having Anton to you. Oh, that was fucking close. And it's like it's kind of you want to move, but you also have to not move. And that gets really very frustrating when Anton is close. You can see I'm kind of dancing him around here, so he doesn't go for me. That was close. And yeah, I got you. You're my bitch, Anton. Oh, I got all the coins. But Anton's still not satisfied, so let's make him eat me. I want to be in the middle. Whoa. Oh no, Bob got eaten by Anton. And this, basically, when Bob dies, it stops the movement, and you cannot control anything other than this, and this is what appears on the screen. Note that the coins spawn randomly each time. I did also have a system for randomizing the maze, but it caused some problems with locking Bob in, and so yeah, I made this pre-made version, but it's fully customizable. Alright, so let's go through the code and see what actually happens behind the screen. So first of all, I have these include libraries here, as well as this define size. Basically, I have math, which I use for random, time I use for random as well, and these two, which is stdio, which is std, I don't know what it stands for, an std library, which basically allows me to use these specific thing. I need the null for the random as well as the random and srand. First off, ball structure. This is what the ball has. The small balls that flies around Bob. It has a location, which is a vector. Velocity is also a vector, and a target, which is also a vector. I create one global variable here, which is my first one. I have 4 in total. Which is the ball size array, which holds the 3 balls, as you can see here, size 3. Now, next one is called the wall. It also has a location, but be noted that this has a pointer. I'm not too sure what pointers do, but I have to do it in this particular sense. Wall also has a boolean is wall, or a boolean it has treasure. Because now we come to the sneaky part. So, let's go through the void display. Here we have an unsigned char called the v size, double v size, which is 50. Now, if the wall is not a wall, in this case it's then a hallway which you can walk on, it shows this particular piece. A rectangle on the location of x and the location of y, which basically means the location of the vector, plus the size of this one, and of course makes it a color which is lighter than the other one. Now, When it is not a wall, it has a chance to create a treasure on it, which doesn't spawn each time. But if it creates a treasure, that is golden in color, slightly golden in the background color, with a smaller golden color on the middle piece. Basically, it's like a circle behind it, which is at location x plus 25, so we get it in the middle of the square instead of the corner, which is when you create a rectangle, it is in the corner of it, as well as size divided by 2, so it's not as big as the entire piece, but a bit smaller. Then the second one here is basically the same thing, except that its size is minus 15 and minus 5, meaning that it will be an oval shape right when you look. It will be let's see, vertical. Now we get to the basically fun part. If it is a wall, which means that boolean is wall equals 1, it creates a wall object, if you would say it like that. It's already created. It creates a rectangle, same as the first one, slightly different color though, so you can see that it's a little darker gray. And then it creates the circle plus rectangle on the middle, so you're sure that it's a wall. Alright, we'll close up with that again. And then I have my second global variable, which is the two-dimensional array of walls, which basically paints the screen from the side, yeah, and all the way down. It basically creates 100 walls, or room for them at least. Alright, let's close up wall. Let's go through the struct player. So here I have the struct player, which has a location again, which is a vector, as well as an array position, which is vector. Then we have an unsigned short, which is a treasure, which is equal to 0. Then we have a boolean life, which is equal to true. Then we have an unsigned char, p size, player size, which is equal to 40. And then we have unsigned char equals new target, which is equal to 0. Now, funny thing here is, now I'm going to show you how the player moves. So these functions I run in the OpenFramework's built-in function called keyRelease, which basically means whenever I let go of a certain key, it's going to run a specific piece of code I put inside there. So I say if key is 119, which is double B, I want to say if bob location .y is less than 15 and bob life equals true, do this piece of code. This particular if statement states that basically if Bob is in the top of the screen, he cannot go out of it in case there are holes or whatever. This is merely a securement for Bob Fiction, and it basically allows him to move if he's not dead. Now, then it runs the movement as well as sets his new target equals 0. I will explain this one later. So let's jump back to the movement. Okay, so we press W and it runs the movement key code. Now what this does is for every time I release, it's gonna run through this double nested for loops here, checking through the array for his location in the array. So basically what I do is Bob is placed at the same location as one of the wall objects. Now it checks which one. When it hits that one, it's gonna check, okay, is the wall that is above Bob in the array, which is j minus 1, false? If it is, then he can move. Then he basically changes Bob's location to a new location plus 50, which is exactly the next piece in the array. This of course also means that if it's not that, it will not be able to move. So if it is true that it's a wall, he won't be able to go through. This is how the collision detection for the walls as well as the movements are conjoined into one. Now this goes for WASD and are all the same. Now, if you remember, I showed you a specific feature which Bob has when he goes to the right. I honestly do not know why he teleports when he goes to the right, but these four codes are exactly the same. The only difference is where it checks and where it moves. And, well, in 3 out of 4 cases it works, but in this particular one it simply just goes full on potato. Alright, moving on. So in the display we basically have Bob is 3 types of circles, and I said it ellipse because that's it's you can morph it a little more. You don't have to use eclipse. You can use ellipse. You can use circle as well. I just like to use this one, and it's basically on the location again, same as the other types. It's pretty easy to understand, as well as the size and a smaller size and an even smaller size, which basically makes that he has a very light color in the edge, a slightly darker color in the middle, and then in the absolute center he has a very darkish color, which is of course of green because it's red, green, blue. Alright, and then I have my third global variable, which is the object Bob, which is our player. Alright, so we move to our enemy. Now, he has a little of the same as the balls, because he basically is a ball with a little more advanced shit on him, and that's about it. So he has an off vector, location, velocity, and target, the same as the balls, as well as he has this one, off vector Bob sight. This is for keeping Anton updated on Bob's position all the time. I'll show you why I need to have this later. So we go into the void display. In this one we can see that the Anton, same as Bob, is built up of circles, and they also increase in size. As you can see, he is very dark in the edges and goes lighter as you go towards the middle on the grayscale. I didn't bother to make any more here. Alright, let's go to the setup. This is a piece of code that Open Frameworks has that runs one time, basically when you set up the program. So let's see what I do here. First off, I go and call this function called srand, which is used in conjunction with the random function, which is called, here you can see it, rand. This basically goes in and gets the time from the computer. So you have a basis to start off of sorts. Now, integer screen size is simply for, what the fuck is that for? Meh. I don't use that for anything, do I? So tap it out, let's see what happens. Yep, don't need it. Alright, so now that we have defined srand, so we move on to the wall generation. Now, what this does is that it actually covers the screen in wall objects, like so, running through x and y, and stuffing these values into the position in the array. This basically means that you cover the entire array in wall objects, and since they are the next one is times 50, it will move so they actually fit all the way. Since this needs to be the same as the size of the object, otherwise it's gonna fuck up. Alright, this is for the outer wall. Now, if x, y is 0, if x is 0 or y is 0 or 9 or 9, it basically has to make the walls 1. This means that all the outer edges of the screen will always be a wall. There is no random customization or shit in there, and this is how to make it faster than typing all of it in myself. Now this is basically the code that generates for if it is not a wall, give that position either has treasure 1 or 0. So this piece of code generates the coins, in a sense. It goes in and checks, okay, we are a position. Is that position a wall? No, it's not. Does Berber have treasure equals random 0 or 1. So it becomes random whether or not there is a coin there. This entire piece is for the middle part. This is the piece I have designed and done in a little old-fashioned-ish way of doing it. This is a little unpractical, but I don't have to. I couldn't really see how to do it any other way. I had to make it specific each time instead of being random, because random fucked up, as I told earlier. All right. So now we move into the piece where Bob is created. Here we have that an unsigned Bob. This is basically telling Bob which position in the array I want him to be in. So let's go through it. We have x is 1 and y is L, and Bob x location, blah blah blah, something like that. So Bob location equals new auth vector, which takes in its x location, which is this entire thing, and says walls 1.8 location, which is the wall that is located in 1.8 in the array, says x and plus that with 25, and does the exact same thing for the y, and then that's basically creates Bob in that specific location in the array as well. So the ball generation is created through a for loop, which where you take 3, which is the size we defined up top, and creates this piece of code. Here we have a short lx and a short ly, which is set to random 500. So it's a random location within 500, which means it's going to be inside the screen somewhere. And then we say balls, which is the area we created for balls, and we say 1. Then we say 0 dot location dot set to these two. So this piece of code sets the location to random. Now this piece of code is crucial that it is always in the beginning set to 0, 0, 0. I will describe this later. Now as for the target, we of course want the balls to go to Bob, so we set the target location to Bob's dot location. This is where they want to go. Now we move on to Anton. And the same thing goes for Anton in a sense. He's also somewhat of a ball. What we do here is that we say location, velocity, and target. He is set in the opposite corner of Bob, and I just typed in the coordinates because I didn't bother to write the entire sentence. Velocity vector set to 0, and target set to Bob location. And now we use Bob side. This location is also set. This vector is also set to Bob's location. And in the beginning, this is the end of the setup. We say cout to move Bob, use WASD. To launch the orbs, click on the click with the mouse. And then it starts with Bob has and whatever amount of treasure Bob has, which is usually 0, and then the setup ends. Now the next piece is going to be set up after the next piece after setup is going to be update and draw. These two functions essentially does the same thing. They run all the time. It is like a while loop that is set to true, in a sense. It keeps updating until, well, you end the program. That's how it goes. Or if I gave it a condition that would stop it or something like that. But this is something that Open Frameworks has made nice for you, so you don't have to worry about it in a sense. So let's go through these pieces again. Now, for this is how I split it up, is that I set in draw I keep only the display function. So in the draw functions I basically only keep all the display. All mechanics and shit is in the update function, just to keep it separate, since they made both, I might as well use them. So in the display I basically go to each and every one of the arrays, each and every one of the wall objects in the two-dimensional array, and run their display function. So this goes through every one of them and runs them all the time. So it's like first one, second one, third one, and so on. And then of course we have bob.display, which does what I showed you earlier, and Anton.display, which is the same thing. And then we have this one for the balls. I could stuff this one up in the struct also, actually, but I made it as the first thing, so I just keep it here. It basically says run through the array of run through the array of the balls, and run this piece of code each time for each. So it says if it is ball 0, it goes into, we'll draw a circle on ball 0's location.x and its location.y, and make the circle 10 in radius. And of course this piece of code, set color, gives it a color before that, and so on and so forth. I have already explained this. So let's go to the interesting thing. Now we go to the update function. This is where all the magic happens, in a sense. Magic of movement in 2D. Alright, so this is how the balls work. We do the same trick for each one. Of course, as I just showed, you can just make a for loop that tests for each and every one of them. Okay, so what I do is I create a vector, another one called direction, or dir for short, which is the target vector minus the location vector. This is basic vector math. This will when I have a square, I can basically show you. It's sort of easy to see. Just a second. Come on. So this location example for this one, this piece up here, would be so to show you, it's quite easy. This coin is denoted by a vector that goes from here out to that one. Now there's also a vector pointing from 0.0 to this one. If I want the vector between the two, I minus them. That's how you get it. So now that we have that one, we normalize it, which means we make it into 1. This basically means that you take the vector and you scale it down so it is one unit of the length that it has. What I then do is that then I scale it, I mean multiply it by multiply each of them by this. Basically means it's gonna get even smaller, very small, very, very small. And then what I do is so now ball dot velocity equals velocity plus direction. Now direction, I could actually call that something else. I could call it acceleration, because that is what it actually is. When I add it to my velocity vector, it's gonna add the acceleration to the velocity. Then I set a limit to it, which means that it can't go higher than this. If I didn't put in the limit, the speed of the object moving would simply just increase and increase and increase and increase to go a billion miles an hour or whatever. What I then do is I say location is equal to location plus velocity. This all comes together in vector math when you say location derived gives velocity and velocity derived gives acceleration. When you basically plus all these together, you actually get something that magically moves. It's cool, super cool and awesome. Now, I of course do like this. This is a small piece that says if new target equals to 0, set target to Bob's location. This is what always comes back to when Bob moves. This is set to 0, so the balls will go back to him. This is how they update and sneak back if you click them out. Alright, so let's move onwards to treasure picking. Now this is an interesting piece of code which also does the huge amount of calculation in. First it goes through each and every one of the array, then it checks for Bob's location in the array specifically, where it checks then if the wall where Bob is has a treasure equals true, then it actually says, okay, fine, we change that to false, so Bob picks up the treasure by adding the treasure to himself, as well as seeing that Bob's treasure is now more than what it just was, and then break to jump out of it. Now, for Anton, it's basically the same as the balls. His target and his location is minused into deer, and it's normalized again, and it's made even slower, so he moves much slower than the balls, which you of course can see as well. And then we do the same trick. We plus it, give it a limit, plus it again, and it moves. Now, if target is if Bob target equals it, not only does the balls get Bob's location, Anton's target gets that location as well. But otherwise, this is the case. So it gets the location as well. So Anton Bob's side sets to Bob's location all the time. This is what Anton uses to basically view Bob all the time. And the reason I had to do this is that when you go into Bob, these vectors are pointers. They're the pointers to the vector in a sense. But this one in Anton is not. This means I can do my little sneaky trick and plus them together like this and minus them. If it was not, it goes in and does some. It has a problem with the pointers, which I don't know how to fix, honestly. So I just made it my workaround. So I have this one off vector derpy, which is basically Bob's side, Anton's Bob side minus his location. So basically it checks how it basically checks the location from Anton to Bob all the time. And that when I use derpy.length, this particular code goes in and checks how long is this vector. So we get a floating number, and we use this little sneaky fella here, which is int sum. Now, if his life is true, what it will do is it will go in and say if length is less than sum, which means that if the distance between Anton and Bob is less than 60, then Bob will get eaten by Anton, and Bob life equal to false. Now this piece of code works in conjunction with this one to keep this loop from going totally haywire and spamming out shit of this thing, because it's just going to say eat, and so on. It'll basically make this thing run all the time, because, well, the sum is less, the length is less than sum. So this is to just make it do it snap one time and then just stop it. Alright, that concludes the update function. So let's move to the, let's see, key release. We went over this. I can do it again just to check it. This is basically how you move Bob. You run each of the movement codes for each key. It works the same every time, and as well as Bob.newTarget gets set to 0. Now for the last part, we go into mouse pressed. Now, if Bob live equals true, this is basically if you're dead, you can't move. So That's how that works. It sets Bob new target equals 1. This basically makes sure that the balls don't fly back to Bob instantly after you click. Now it runs through the ball array again, where it sets the target to X. Now X in this sense is that mouse pressed means that X and Y will be set to the exact place of the mouse button. I could define which type of button I want as well, but I haven't bothered. You can do it with both left click and right click in this game. As well as this, Anton's target also gets changed to the same. So this is how Anton sneaks after the balls. He basically doesn't, he just gets the same place to go. And that pretty much sums up what I did for this project. Thank you for watching. It was fun making, even though it was a bit of a pressed time schedule. See ya.